China conducts test launch of hypersonic air-to-air missile over Inner Mongolia. Date: March 1, 2025. Introduction. On March 1, 2025, China conducted a successful test launch of a hypersonic air-to-air missile over the Inner Mongolia Autonomous Region, marking a significant milestone in its military capabilities. Designed specifically to target advanced stealth bombers such as the US B-21 Raider, this missile boasts a remarkable range of over 1,000 kilometers and can reach speeds of Mach 9. This advancement is poised to reshape aerial combat dynamics and shift power balances within the Indo-Pacific region. Timeline of developments. 1. January 19, 2025, China officially announced the completion of the final testing phase for the hypersonic missile, representing a pivotal advancement in military technology. 2. February 6, 2025, further details emerged regarding the ongoing heat resistance testing of the missile, confirming its development progress and operational readiness. 3. March 1, 2025, the successful test launch was reported, sparking discussions about its implications for global military strategy. Key features of the hypersonic missile. Speed and range. The hypersonic missile's ability to achieve speeds of Mach 9 and operate over a range exceeding 1,000 kilometers allows it to engage targets significantly beyond the reach of current air-to-air missiles, which typically have ranges of 350 to 400 kilometers. This rapid trajectory makes interception by existing missile defense systems exceedingly difficult. Targeting capabilities. It is engineered to target high-value assets such as transport planes, refueling aircraft, and early warning systems, targets that are generally more vulnerable due to their slower speeds. The potential to neutralize these assets could redefine air superiority in the Indo-Pacific. Significance of the launch. The development and successful testing of this hypersonic air-to-air missile are viewed as a game-changer in modern military strategy. Analysts recognize the missile as a formidable threat to advanced stealth aircraft, with its specifications positioning it as a leading contender in aerial warfare. The implications of this technological leap are profound, particularly concerning U.S. military strategies and aircraft. Sources and insights. 1. Indo-Pacific News reported the missile specifications and the successful test launch, emphasizing its capability against advanced stealth bombers. 2. BulgarianMilitary.com provided a detailed analysis of the missile's design and testing, highlighting the engineering challenges associated with hypersonic weapons. The site emphasized the missile's extensive heat resistance tests, simulating extreme conditions necessary for its operational viability. 3. Overt Defense discussed the technological and economic challenges of developing hypersonic systems, noting that only a few countries, including China, the US, and Russia, are significantly investing in this technology. This source also focused on the missile's potential to redefine air combat dynamics. Implications for US military strategy. The emergence of China's hypersonic missile presents a direct challenge to U.S. military capabilities, particularly regarding its newest stealth aircraft, the B-21 Raider. While designed for minimal detection, the B-21 now faces a greater threat from hypersonic weapons. The U.S. military will need to innovate and adapt rapidly to counteract this emerging threat, potentially altering its existing strategies and operational frameworks. Future considerations. The successful integration of hypersonic missiles into China's military arsenal will necessitate careful consideration of suitable platforms for deployment, including advanced fighter jets such as the Chengdu J-20 and multi-role aircraft like the Shenyang J-16. The evolution of these aircraft to accommodate hypersonic capabilities will significantly enhance China's air power. Conclusion. China's successful test launch of a hypersonic air-to-air missile represents a critical advancement in military technology that may reshape the strategic landscape in the Indo-Pacific region. As global military powers reassess their strategies in light of this development, the nature of aerial combat is on the brink of a dramatic evolution. The integration of hypersonic capabilities into military arsenals worldwide will require a re-evaluation of defense strategies to address the rapid advancements in missile technology. The content discusses China's recent successful test launch of a hypersonic air-to-air missile, highlighting its impressive specifications and potential implications for military dynamics, particularly in the Indo-Pacific region. Here are some counterintuitive insights drawn from the details. 1. Range versus speed. While hypersonic missiles are often celebrated for their incredible speed Mach 9, the focus on range over 1,000 kilometers may seem contradictory. Typically, one might assume that increasing speed would necessitate a reduction in range due to fuel consumption and heat management challenges. However, advancements in propulsion and materials have allowed this missile to achieve both exceptional speed and range, showcasing a complex evolution in missile technology. 2. Targeting stealth bombers. The missile is designed primarily to counter advanced stealth bombers like the US B-21 Raider. This choice underscores a strategic pivot. Rather than developing missiles solely for traditional aerial engagements, China is proactively addressing the technological advancements of its adversaries. This approach may seem counterintuitive because one might expect a focus on more conventional targets. Yet it reflects a recognition of the changing landscape of aerial warfare, where stealth technology is increasingly prevalent. 3. Economic considerations. Developing hypersonic systems is framed as both a technological and economic challenge, which might seem contradictory given the immense military budgets of countries like China and the US. While it's easy to assume that financial resources would guarantee successful missile development, the reality is that the engineering and testing required for hypersonic technologies are extraordinarily complex and costly. This suggests that even a nation with substantial funding might face unforeseen hurdles, emphasizing that financial backing alone does not equate to successful technological advancement. For a role of non-combat aircraft, the discussion around the Y-20 strategic airlift aircraft potentially being modified to carry hypersonic missiles is intriguing. Typically, one might expect dedicated combat aircraft to be the primary platforms for such advanced weaponry. However, this indicates a strategic evolution where logistics and transport aircraft are being considered for offensive roles, which could redefine traditional military doctrines regarding the use of different types of aircraft in combat scenarios. 5. Stealth versus speed. The development of hypersonic missiles poses a direct challenge to stealth technology. It's counterintuitive to think that advancements in stealth technology might be rendered less effective by faster and more unpredictable threats. The assumption has been that stealth would provide a significant advantage in avoiding detection, yet hypersonic missiles could change the nature of engagement, suggesting that future aerial combat may prioritize speed and unpredictability over stealth. 6. Military strategy versus technological development. The narrative suggests that the technological advancements in hypersonic missiles will compel the US to innovate rapidly, which implies a reactive rather than proactive military strategy. It might seem that technological supremacy would provide a strategic advantage. But the need to adapt quickly to emerging threats indicates that technological advancements can disrupt established military strategies more fundamentally than anticipated. 7. Integration challenges. While the missile specifications are awe-inspiring, the integration of such advanced systems into existing military frameworks poses significant challenges. The assumption might be that new technology seamlessly enhances military capability, but the reality is that operationalizing hypersonic missiles involves substantial adaptations in command and control systems, which can create vulnerabilities during the transition phase. These insights illustrate the complex and often counterintuitive dynamics at play in contemporary military developments, particularly concerning advanced weapon systems like hypersonic missiles. The intersection of technology strategy and economics shapes a landscape where traditional assumptions about warfare and military capabilities are increasingly being challenged. The recent test launch of a hypersonic air-to-air missile by China over the Inner Mongolia autonomous region is a pivotal moment in military technology that deserves closer scrutiny. While many reports have highlighted its impressive specifications, speed exceeding Mach 9 and range over 1,000 kilometers, several significant aspects may be overlooked yet hold immense strategic importance. 1. Technological advancements in hypersonic capabilities. One of the most commonly acknowledged features of this missile is its speed and range. However, the underlying technological advancements enabling these capabilities are crucial. The missile's ability to withstand extreme heat during hypersonic flight is a monumental engineering feat. The testing protocol involves using advanced wind tunnels that can simulate conditions typically reserved for space missions with temperatures exceeding 200 degrees Celsius. This detail is significant for several reasons. Engineering challenges. Developing materials and electronics to survive such conditions is no trivial task. It necessitates innovations in materials science which could have broader applications beyond military technology, influencing aerospace engineering, automotive industries, and even commercial aviation. Operational viability. The successful heat resistance testing indicates that China is not merely building a prototype but is moving toward operational readiness. This transition from concept to deployment is crucial as it reflects an ability to integrate advanced technology into functional weaponry. 2. Strategic targeting of high-value assets. The missile is specifically designed to engage advanced stealth aircraft like the US B-21 Raider. While many discussions center on the missile's direct threat to aerial combat, the implications of targeting high-value assets such as refueling aircraft transport planes and early warning systems are often underappreciated. Redefining air superiority. By effectively neutralizing these critical support systems, China could significantly alter the dynamics of air superiority in the Indo-Pacific region. This capability allows for a more aggressive posture where adversaries must account for not just frontline fighters but also their logistical and support lines. Psychological warfare. The mere existence and demonstration of such a missile can induce a state of uncertainty and fear among adversary forces. This psychological dimension of warfare can demoralize enemy troops and complicate military planning. 3. Impact on U.S. military strategy. While many sources note the implications for U.S. military strategy, the nuances of how this development could influence American defense operations are often glossed over. Shifts in defense spending. The U.S. may be compelled to increase its defense budget not merely for more advanced stealth technology but also for countermeasures against hypersonic threats. This could lead to a reallocation of resources that may affect other military programs. Potential arms race. The introduction of hypersonic missiles by China could trigger an arms race, pushing other nations including the US and its allies to accelerate their own hypersonic programs. This dynamic could lead to heightened tensions and instability in international relations. 4. Integration with other platforms. While there are mentions of potential platforms for deploying the hypersonic missiles such as the Chengdu J-20 and Shenyang J-16, the broader implications of integrating such technology into existing military frameworks can be overlooked. Multi-role capability. The versatility of platforms like the J-20 means that as these hypersonic missiles are integrated, they can be used not just for air superiority but for precision strikes, reconnaissance, and even strategic bombing missions. This multipurpose capability can enhance the operational flexibility of the Chinese Air Force. Command and control systems. The successful deployment of hypersonic missiles also hinges on robust command and control systems. The ability to accurately target and launch these missiles is essential and could lead to advancements in military communications and intelligence sharing, which are critical for modern warfare. 5. Global military landscape changes. The emergence of China's hypersonic air-to-air missile is not merely a national issue but has global implications. Alliance dynamics. Countries in the Indo-Pacific region may feel compelled to re-evaluate their alliances and partnerships. Nations like Japan and Australia, traditionally aligned with U.S. military strategies, may seek enhanced cooperation or even develop their own hypersonic capabilities in response to perceived threats. International norms and treaties. The development of hypersonic weapons challenges existing international treaties and norms around arms control. Discussions around limiting these weapons may become increasingly complex as nations grapple with the implications of a new class of arms that operates outside traditional categories. Conclusion. While the hypersonic air-to-air missile test by China is a significant development in military technology, the broader context surrounding its implications is critical for understanding its impact. The technological advancement's strategic targeting capabilities impacts on U.S. military strategy integration with existing platforms and global military dynamics all contribute to a complex and evolving landscape in military affairs. These nuances highlight the importance of not just recognizing the capabilities of such weapons but also understanding the wider implications they carry for international security and military strategy. As countries adapt to these advancements, the landscape of warfare and defense will continue to evolve, ushering in new challenges and opportunities for global powers. 1. Technological advancements in hypersonic weapons. China's successful test launch of a hypersonic air-to-air missile demonstrates a significant leap in military technology. With a speed of Mach 9 and a range exceeding 1,000 kilometers. This missile poses a formidable challenge to existing air defense systems. The ability to travel at such high velocities allows it to reach targets much faster than traditional missiles, thus reducing the enemy's response time. This technological superiority not only enhances China's air combat capabilities but also shifts the dynamics of aerial warfare, particularly in the Indo-Pacific region. 2. Strategic implications for air superiority. The missile's design specifically targets advanced stealth bombers like the US B-21 Raider, which have traditionally been considered critical assets in maintaining air superiority. The operational readiness of such hypersonic missiles could redefine the strategic balance of power, compelling nations, especially the United States, to reassess their military strategies and invest in countermeasures. The implications extend beyond individual military engagements, as the presence of hypersonic weapons could deter adversaries and influence geopolitical stability in the region. 3. Challenges and considerations for deployment. The successful integration of hypersonic missiles into China's military arsenal involves multiple considerations, including the choice of aircraft capable of carrying and deploying these advanced weapons. Potential carriers like the Chengdu J-20 and Shenyang J-16 must be evaluated for their payload capacities, operational versatility, and stealth capabilities. Additionally, the logistical and operational frameworks for deploying hypersonic missiles will require robust command and control systems to maximize their effectiveness across various combat scenarios. 4. Economic and engineering challenges. The development of hypersonic technologies presents both economic and engineering challenges. The construction and operation of advanced wind tunnels for testing, as well as the complex engineering required to ensure missile reliability at extreme speeds, demand significant investment. Only a few nations, including China, the US, and Russia, are currently pursuing these advancements, indicating a high barrier to entry in the hypersonic arms race. The ongoing competition in this domain will likely escalate military expenditures and drive innovation, further reshaping global military landscapes. These points encapsulate the critical aspects of China's hypersonic missile development, highlighting its implications for military strategy, technology, and international relations. 1. The V-2 rocket. Germany. World War II. The V-2 rocket, developed by Wernher von Braun and his team, was the world's first long-range guided ballistic missile. Its development marked a significant advance in missile technology with the capability to reach speeds exceeding Mach 5. The V-2 was used by Nazi Germany during World War II to target Allied cities, causing significant destruction. Like China's hypersonic missile, the V-2's speed and range rendered it difficult to intercept, leading to a new era in warfare where speed became a critical factor in military strategy. 2. The Soviet Union's R-7 Semyorka. Cold War. The R-7 Semyorka was the world's first intercontinental ballistic missile ICBM, developed by the Soviet Union in the late 1950s. Capable of delivering nuclear warheads over long distances, it played a crucial role in the Cold War dynamics. The R-7's ability to travel at high speeds and its long-range transformed military strategies similar to the strategic implications of hypersonic missiles today. The R-7 was a pivotal development in missile technology, leading to the space race and changing global power balances. 3. The U.S. AGM-183A ARRW current development. The AGM-183A air-launched rapid response weapon ARRW is a hypersonic missile currently being developed by the United States. Designed to be launched from bombers and fighter jets. The ARRW aims to provide the U.S. military with a fast and agile strike capability against high-value targets. Similar to China's recent test of a hypersonic air-to-air missile, the ARRW emphasizes speed and range with the potential to significantly alter the landscape of aerial combat and military strategy in the modern era. The ARRW's development reflects ongoing global competition in hypersonic technology, paralleling the advancements seen in China's missile capabilities. Future outlook on China's hypersonic air-to-air missile development. China's successful test launch of a hypersonic air-to-air missile marks a watershed moment in military technology, influencing both regional and global security dynamics. As the capabilities of such advanced weaponry evolve, several predictions can be made regarding their implications on military strategy, international relations, and technological advancements. 1. Transformation of aerial combat. The introduction of hypersonic missiles capable of speeds exceeding Mach 9 and ranges over 1,000 kilometers will fundamentally alter aerial combat. Traditional air-to-air engagements will shift as these missiles challenge existing defense systems. Future air combat will likely see an emphasis on stealth and speed, compelling nations to rethink their tactical approaches. Countries may invest in counter-hypersonic technologies, including faster interceptor systems and advanced electronic warfare measures to disrupt hypersonic missile guidance. 2. Strategic military posturing in the Indo-Pacific. China's hypersonic capabilities are poised to reshape the balance of power in the Indo-Pacific region. As tensions escalate in areas like the South China Sea and Taiwan Strait, the ability to strike from long distances could embolden China's military posturing. This development may prompt neighboring countries and the United States to enhance their military alliances, increase defense spending, and possibly redeploy forces to counterbalance China's growing power. Expect to see an increase in joint military exercises among U.S. allies, as well as a focus on deterrence strategies. 3. Impact on U.S. military strategy. The U.S. will have to reassess its military strategies in light of China's advancements in hypersonic technology. The B-21 Raider and other stealth aircraft may require enhanced defensive systems or modifications to improve survivability against hypersonic threats. The U.S. might accelerate its own hypersonic missile programs and invest in research for new technologies to maintain air superiority. This arms race could lead to increased military spending and innovation, particularly in missile defense and detection systems. 4. Technological advancements and collaboration. As hypersonic technology advances, there will be a push for greater collaboration between nations in developing countermeasures and defense systems. This could result in international partnerships focused on missile defense research, leading to the development of new materials and technologies that could withstand hypersonic speeds. Enhanced collaboration between defense contractors and government agencies will be essential for countries aiming to keep pace with evolving threats. 5. Economic implications. The development and testing of hypersonic weapons come with significant economic implications. The high costs associated with research, development, and deployment may impact national budgets, leading to potential reallocations of funding from other sectors. Countries may face pressure to justify military expenditures amidst domestic economic challenges. Conversely, the defense industry may see growth opportunities as nations seek to procure cutting-edge technologies and systems capable of countering hypersonic threats. 6. Global arms control discussions. The emergence of hypersonic weapons could reignite discussions around arms control treaties. As nations recognize the destabilizing potential of these weapons, there may be calls for international agreements to limit their development and deployment. However, achieving consensus on regulations will be challenging given the strategic advantages these weapons provide. Future diplomatic efforts may focus on establishing protocols for transparency and confidence-building measures to reduce the risk of miscalculation. 7. Adoption of multi-domain warfare. The integration of hypersonic missiles into military operations is likely to promote the adoption of multi-domain warfare strategies. As hypersonic systems can engage targets from extensive distances, military planners will need to coordinate air, land, sea, cyber, and space capabilities effectively. Future conflicts may involve complex interactions across these domains, with hypersonic missiles serving as critical components of integrated military operations. 8. Future of defense technologies. The race to enhance hypersonic capabilities will spur innovation in related technologies, including propulsion systems, materials science, and artificial intelligence. Research into heat-resistant materials will advance, potentially benefiting various industries beyond defense. The need for advanced tracking and targeting systems will also drive developments in AI and machine learning aimed at improving accuracy and response times against fast-moving targets. Conclusion. China's hypersonic air-to-air missile development heralds a new era in military technology, demanding a re-evaluation of existing strategies and alliances. The implications for global security, military innovation, and international relations are profound as nations grapple with the challenges posed by such advanced weaponry. As this landscape continues to evolve, the focus will be on maintaining a balance between technological advancements and strategic stability to mitigate the risks associated with emerging military capabilities. The future of warfare may very well hinge on how effectively nations adapt to the realities of hypersonic technologies.